Imagine a rubber band stretched around an apple. You can smoothly shrink it down to a point without breaking the rubber band or leaving the apple's surface. Now let's delve deeper into this analogy to understand the Poincaré conjecture. This conjecture, named after the French mathematician Henri Poincaré, who proposed it in the early 20th century, is all about shapes and spaces. Consider our apple. It's a simple, closed shape. It has no holes, no tunnels, no twists or turns. It's just a plain, three-dimensional object. The rubber band represents a loop on the surface of the apple. You can shrink this loop without it breaking or leaving the surface of the apple, until it becomes a single point. This is the core idea behind the Poincaré conjecture. It states that if any loop on a three-dimensional shape can be shrunk to a point without breaking or leaving the surface, then that shape is essentially a three-dimensional sphere. But here's the complexity. The conjecture doesn't just apply to physical objects like apples or rubber bands. It's about understanding the structure of three-dimensional spaces, even those that we cannot visualize or physically touch. Think about our universe. It's a vast, three-dimensional space, but does it have the same property as our apple? Can we take any loop in the universe and shrink it down to a point without it breaking or leaving the universe? If so, the Poincaré conjecture would imply that our universe is, in a mathematical sense, a three-dimensional sphere. But hold on. The universe isn't made of rubber or apple skin. It's a space filled with galaxies, stars, and planets. How can we even begin to apply the idea of shrinking loops in such a context? Well, that's where the beauty of mathematics comes in. We don't need physical rubber bands or apples. We use abstract mathematical concepts to comprehend the fundamental nature of three-dimensional spaces. Now, if we think about this in terms of a three-dimensional space like our universe, things start to get a bit more complicated. The Poincaré conjecture, proposed by French mathematician Henri Poincaré in 1904, is a concept in the field of topology, the mathematical study of shapes and spaces. In essence, the Poincaré conjecture is all about understanding the nature of three-dimensional shapes. Think of a sphere, for instance. According to the conjecture, any shape without holes is essentially a sphere. In other words, if you can stretch and deform it without tearing or gluing and it remains finite, then it must be a sphere. This is a fundamental principle in the field of topology which deals with properties of space that are preserved under continuous transformations. For over a century, the Poincaré conjecture remained one of the most notorious unsolved problems in mathematics. It was a tantalizing puzzle, attracting some of the greatest minds in the field, but it proved to be an elusive challenge, resisting all attempts at resolution. It was such a compelling problem that the Clay Mathematics Institute included it in its 7 Millennium Prize problems, offering $1 million reward for a solution. Then, in the early 21st century, a Russian mathematician named Grigori Perelman entered the scene. Working largely on his own, Perelman built upon the work of Richard Hamilton to develop a proof for the Poincaré conjecture. His work was groundbreaking, offering a solution to a problem that had perplexed mathematicians for over 100 years. Despite the promise of fame and fortune, Perelman declined both the Fields Medal and the $1 million prize, choosing instead to continue his work in relative obscurity. The Poincaré conjecture is much more than an abstract mathematical problem. It's a window into the nature of the universe itself, giving us a framework to understand the shape of the cosmos and the spaces that exist within it. It challenges our perceptions of reality, pushing us to think beyond the tangible and observable, and reach into the realm of the abstract and theoretical. And there we have it, the Poincaré conjecture, a simple-sounding problem that delves into the complexities of our universe and beyond. In the world of mathematics, problems like the Poincaré conjecture remind us of the vast and mysterious nature of the universe we inhabit. By delving into these enigmas, we've journeyed through the complex tapestry of mathematics, unveiling its inherent beauty and depth. These explorations offer us a glimpse into the infinite, provoking awe and sparking our curiosity. As we continue to explore these mysteries, who knows what other fascinating puzzles we'll uncover. Until then, keep pondering and keep exploring. Remember, the universe is infinite, and so is our quest for understanding.